Okay. Thanks for that, Sarah. So good day, everyone. Welcome to another ESCoE seminar, a webinar, sorry, on economic measurement. Before we start today's webinar, I'd like to inform you that there is a change in date to the next ESCoE webinar. This one will cover regional GDP review undertaken by Mari Sparridge and her team at the Fraser Allender Institute on Wednesday, the 2nd of April, 2025, 12 o'clock UK time. So for a date for your diaries, Wednesday, 2nd of April, 12 o'clock UK time. So for those of you who do not know me, my name is Sanjeev Mahajan. I work in economic statistics within the ONS, the Office for National Statistics in the UK, as the head of methods and research engagement. Separately, I'm one of the 5 supporting editors for the 2025 SNA, as well as a member of the UN Advisory Expert Group on National Accounts. 2 notable milestones I just want to mention that are occurring this month for your attention. The 2025 SNA has recently been adopted as the updated international standard on national accounts by the United Nations Statistics Commission. Similarly, the new version of the Balance of Payments Manual and the International Investment Position, version 7, is expected to be adopted this month. If you wish to know more, please contact me and happy to help in that context. So moving to today's presentation, which is on seasonally adjusting UK inflation by Hugh Dixon. The presentation will last around about 40 minutes, followed by the views of the discussant, Paul Smith, for 10 minutes. There will be an opportunity for questions and answers at the end of the session, possibly around about the 10 minutes mark. And this session will be recorded and the presentation will be placed on the ESCoE website. I think the question and answer session we don't include in that unless that's changed. So moving on to Hugh himself. Hugh is a Professor of Economics at Cardiff University and the lead researcher on economic measurement at NIESR. Hugh is an authority on inflation and inflation modelling. He's contributed insightful analysis to NIESR's monthly commentary on ONS inflation figures and inputs into the NIESR Economic Outlook forecast for inflation. Hugh is a busy person. He's written several papers using the ONS CPI price quoted data and developed statistical models to better measure the rigidity of nominal prices to better understand the effects of monetary policy. Hugh has also worked on related projects using similar data with the Bank of England, Banque de France, and Bank of Greece and the European Central Bank. And obviously, we all know that inflation is a really important variable, very important for policy purposes, used every month by the Bank of England. It's also used as an indicator for various aspects. So seasonally adjusting and improving the quality of such a variable is very important. Mind you, revisions are as well in terms of interpreting the data. So what I'll do now, without ado, in terms of any time taken from my part, hand over to Hugh to share his screen and get going. Hugh.
Thank you. I'll just share my screen. Have you got it there? It's at Control L. It's at the end there. So let me just see if
Can you put it in full screen mode?
I'm about to do that, but I'm getting it back to the beginning, and then there it is. It's full screen mode. Have you got it there?
Excellent. We can hear you and we can see it.
Excellent. Thank you very much for that introduction. So basically, and in fact, most components of GDP, trade data, and so on. However, currently it does not seasonally adjust CPI or CPIH. Now, let's just take a little step back in the past. So this issue has been looked at before in the context of RPI, and there's a paper by Michael Baxter from the ONS, and they decided not to adjust RPI. And he highlighted 3 reasons, which are still valid today, really. Much of the seasonality that you see in CPI or RPI is due to annual changes in indirect taxes, which are caused by government action rather than climatic or socioeconomic factors. Seasonally adjusting RPI is at odds with the policy that RPI and its components are never revised. Obviously, as Sanjeev intimated, seasonally adjusted series are subject to revision, and we'll go into a lot more detail about that towards the end of the talk. And the annual inflation rate of the seasonally adjusted series may differ from the original data, causing confusion with regard to the statutory and contractual uses of RPI. So what did the ONS decide to do back in the day? Well, they decided to adjust RPI-Y, which is RPI excluding indirect taxes, and the resultant series is called SARPI. So they did publish this for a while, but it was discontinued in 2014. So currently, the ONS doesn't seasonally adjust any of the CPI series. As I said, the same arguments really apply to the CPI and CPIH as applied to RPI back in 1999. It did actually publish CPI-Y, that CPI excluding indirect taxes, but that was discontinued in December 2021 due to lack of interest. Nobody was paying much attention to it. So why is the ONS revisiting the issue? Well, one big factor, I think, is that several NSIs have started to produce seasonally adjusted CPI equivalents. Just to list a few, these include the US Bureau of Labor Statistics, which publishes the main US CPI series, Canada, Germany, France, Japan, and Australia. I think there are about 12 I found from around the world. So it's not by no means universal, but it's certainly going on. The almost universal method which is used by these various bureaus is something what's called the US Census X. Well, we're up to 12 or 13 now. I think it started off at 10. And this is a method that was developed in the 1960s, and it's developed over the preceding decades. And also the software for implementing it has greatly improved, which makes it easier to do. And there are add-ons like CIATS and Tramo and so on. So it's become easier to do, I think. And so this talk, I must say, is based on a report written for the ONS by myself and Monica George Michael, who's here to answer any difficult questions if they come up. And I'd like to thank various people from the CPI team at Newport and also the august members of the APCPT advisory panel, one of whom is Paul Smith. They've given a lot of comments on a previous draft. And it should be published as a NIESR discussion paper in April. So you'll be able to see there'll be a lot more detail there. And there's quite a lot of tables and background stuff that we'll also be publishing for those of you who are interested in seasonal adjustment. So let's just take a quick step back and look at the data. There are three different ways really of representing inflation data, and I think we all know what the inflation data is, but it's worth just going over this. So firstly, there's the CPI index. This is an index. Currently, the index is set at 100 in 2015, and this gives you the level of an index of the price level in the UK. Second is the annual or year-on-year inflation. This is what most people think of as inflation. This is the headline inflation which is reported in the news and reflects the proportional change in the CPI index in the last 12 months. Third, there's monthly or month-on-month inflation. This is the inflation that happens in 1 month, the change comparing the current month and the previous month. All three of these are different ways of representing exactly the same data, and indeed you can derive all the other two from any of the one. So from the index, you can derive the annual and monthly figures. You can derive the annual from the monthly quite easily, and the CPI index from the monthly. You sort of need to have one level observation. If you're differencing, you're taking a monthly growth rate, you sort of lose the level, a bit like differentiation. So you need at least one observation to give you the level, so you can recover the whole CPI series. And the annual, you can do a similar thing. So whilst the ONS reports all three, by far the greatest attention is given to annual inflation. Most people don't really look at the other things. But seasonal adjustment really has little effect on the annual figure. Taking a 12-month perspective, the annual figure looks over all 12 months. So in a sense, the monthly variation is sort of automatically cancelled out. So its main effect is really to adjust the CPI index itself and monthly inflation, as we'll see. Where is the data we're using coming from? It's most of the data we use comes from the consumer price inflation tables. These are published each month on the ONS website, and they're basically updated because of the no revision policy. Most of it remains the same. They just add another line to it for the current month. And in particular, we look at tables 56 and 57 for CPIH and CPI. I gather the table numbers are going to vary from next month onwards, but they'll have new numbers, but it'll be the same tables. And these give you the CPI index from January 1988 to the present, broken down into the all items index, which is the headline, and then the 2, 3, and 4 digit COE expenditure variations, plus some aggregates. There's about 140 series in total across those two tables. So we can just look at the first question, quite a simple one. Is UK CPI data seasonal? Well, there are two basic aspects of seasonality. One is, if you like, within year seasonality. Are the months different? So is January different to July, and so on and so forth? And secondly, there are correlations at seasonal intervals, i.e. 12 months. These are slightly different, though obviously related. Within year seasonality is sufficient for seasonal correlation, because obviously if you've got within year seasonality, January will be correlated with January, so that'll give you a 12-month correlation. But seasonal correlations are not sufficient, at least in the long run, for within year seasonality. So you can have 12-month correlations, but they can flip around over time. So if you're looking over a long time series, they needn't give rise to within year seasonality, although they will do for shorter time periods. So let's first concentrate on A, within year seasonality. Do the months differ? So here we can focus on the monthly inflation rate. And we've got data from 1988 to 2024. That gives us 36 years, or if you like, 36 observations for each month. So does average monthly inflation differ across the 12 calendar months? And the answer is yes. So here's a figure, and it covers the whole period, 1988 to 2024. Obviously, you can track these things with moving averages and so on. But this is, summarizes all 36 years. And as we can see, the blue dotted line gives you the average over the whole period across all months. And we can see that in January, on average, inflation price levels tend to fall, and the inflation rate is negative. Ditto, the same applies to July. In most other months, you've got positive inflation on average, but it does vary. And April is the cruelest month, to quote somebody, Elliot, but it's positive in most of the other months, but it does vary across the months. So obviously you can use statistical tests to test which ones these differences are significant, but just using ocular econometrics, you can see that they are different. And of course, April, as we previously mentioned, April is obviously dominated by budget effects. And some of these have been very large. For example, Norman Lamont's increase of VAT by 2.5% in April 1991, I think it was. These can be very big. But if we look at we've got January and July have falls, but you also get a bit of a bounce back in February and August as prices go back to their more normal levels. So February and August are a little bit elevated as well. So we can look in this a little bit more detail. So that's a simple way to capture within year variation, a very crude way, but it's simply to use monthly dummies. So we can regress month-on-month inflation for each of the 432 months with a constant and 11 monthly dummies. And by construction, the fitted values for each month will be given by the monthly dummy, and the residuals across the year for that month will be approximately 0. So a simple measure of this aspect of seasonality is the R-squared for this simple regression. So we can break up the CPI index into its subcomponents down to the 4-digit level. So basically, it sort of gives us a fairly simple summary statistic, which we can all understand which we can apply at different levels. So for all items, then this simple regression gives us 52%, an R squared of 52%, and the mean is 53%. But there's great heterogeneity, and we'll see that in the next diagram. But if we go to the 2-digit level, we get the mean of 28% for the R squared. And at the 4 digits, it's a little bit less. So, the figures differ slightly between CPI and CPIH, but nothing great. So what I quite like is this cumulative distribution. So along the horizontal axis, we can see the R squared. Sorry, I've only got 2. I should have 3 digits there. But anyway, as you go from left to right, the R squared is getting bigger. And the maximum is 0.83, which I think is for garments, one of the subdivisions of clothing and footwear, the most seasonal element. And at the bottom, you've got 0.02, which is very small for some aspect of telecommunications, I think. And it goes up. And as you can see, it's not quite a straight line, but it goes up. The vertical axis is the share of CPI, which has an R squared up to the particular value. Goes up to 1,000, and as you can see, it increases. It's sort of, this reflects great heterogeneity. Some have very low values, some have very high values, and there's no particular clumping in the middle. So there's a lot of heterogeneity as you go into the various COE subdivisions. What about seasonal autocorrelation? Again, you could do some very simple things here. Is there 12-month autocorrelation of inflation? And the answer is yes, it's certainly present. If you run a simple AR12 on monthly UK inflation, you'll get a highly significant coefficient on the 12th lag, even if you have monthly dummies. So I often do stuff with monthly dummies, and AR12, the 12th lag still comes up. So yeah, there's clearly 12-month autocorrelation in the data. So that aspect of seasonality is there. So we have various seasonality tests, formal statistical tests, which are is part of the X13 process. Some of these focus on within-year seasonality, the monthly dummies test or the Kruskal-Wallis test, and some focus more on seasonal autocorrelation, correlograms and spectral peaks and so on. So we tend to place a little bit more focus on the Kruskal-Wallis test because it's non-parametric, and I think if you don't have within-year seasonality, then it's not, seasonality is maybe not so important. Okay, so the data is there is seasonality in the UK CPI data, although there's great heterogeneity. So how do you seasonally adjust the data? Well, we needed to come up with a method. There's about 140 series which need to be adjusted, and these are found, as I say, in tables 56 and 57 of the consumer price inflation tables. The almost universally applied method is some variant of the US Census X12, X13 method, possibly with or without the CIATS or TRAMO add-ons. Now, this is a framework that can be applied in different ways, but its core, it uses moving averages and the ARIMA framework. And we found that we tried out various different types of software to do this, and we found that JDimitra was the easiest to use and also had good default settings, which were able to adjust easily for problematic time series. So if the CPI team is going to do this, perform this task of seasonally adjusting the UK data, it needs to do something which can be done in relatively little time, because it has to do it once a month, along with all the other things it has to do. And so this is what we think is what we recommend. So there are other alternatives which we can discuss if you like. So the method basically breaks down the time series into a trend and cycle. So the trend and cycle, that's captured by moving averages of different types, and then it captures the seasonal and irregular components. The process of seasonal adjustment really involves identifying the seasonal element and taking it out of the time series. So that's what seasonal adjustment is. Now, one of the main issues when you look at this is that there are big outliers in the CPI data. So there's Norman Lamont's he was a Chancellor of the Exchequer, and he increased VAT by 2.5% in April 1991. So that's 2.5% in 1 month. That's more than the change you see in a whole year in many things. There have been other big changes in VAT, of course, since then. And there's also been big off-gen price gap increases, which have affected not only the energy parts of COE-COP, but also the all items. And in April and October 2022, we also saw very big month-on-month increases in CPI. So how does seasonal adjustment work? Well, basically, you take the outliers out, you identify the outliers, and then you take them out, then you do the seasonal adjustment, and then you put them back in. So essentially, the outliers appear, they're sort of maintained in the seasonally adjusted data in the irregular part. So this really raised the challenge, if you like. Since a lot of some of these outliers are seasonal, the April budgets, etc., will the seasonal adjusted series have residual seasonality? By that, I mean, once you've seasonally adjusted the series, and you look at the seasonally adjusted series, when you do your seasonality tests, will it have residual seasonality? And the answer, well, it's yes and no, really, but the answer is no. But or it can be no if you make the right choices within the seasonal adjustment process. And the main thing we found that you had to do was adjusting the sensitivity for outliers. Okay, so let's have a look at what we actually did. So we made specific choices. There are many alternatives within the framework, and we had to choose one to do. We did try some alternatives, of course, but we reported on what we thought was the best one. So firstly, we did not adjust time series that were not seasonal, that failed the seasonality tests. So if a series isn't seasonal, we didn't adjust it. Obviously, you can adjust a non-seasonal series, but it'll just return something that looks very, very similar. So, and the guidelines, both for Eurostat and for the ONS, is that you shouldn't do this. So that's what we did. Secondly, we imposed log transformation of the CPI levels. So again, this is something that one of the tests that's part of the series. It tests whether it's best to log transform it. And in some cases, it does do it. In other cases, it doesn't. We impose it on advice from one of the experts. We impose this, and to us, it makes most sense. Sort of if you're looking at proportional changes, the actual absolute changes aren't really what matters. It's what's happening proportionally that matters. So I think that makes perfect sense. And thirdly, as a matter of practicality, we adopted the default settings within JD, except when they didn't work. Again, this is because there's simply so many series. If we were just looking at one or two series, we had lots of time. You can do bespoke stuff and really tailor the seasonal adjustment to a particular series. But obviously, with 140 series, that's not something which you're going to be able to do on a monthly basis. So it's not practical to have bespoke SA for each series. But we do adjust the JD series and when required. And as I say, the most common adjustment was allowing for more outliers, the outlier sensitivity settings. But there were some other things we did as well. Okay, so for CPI and CPIH, we broke up this into three segments. And those were 1988 to 2003, 1997 to 2018, 2012 to 2024. Basically, the reason is that the JD selects a specific ARIMA model for the whole period adjusted, and breaking it up allows for a different model to be used for each subperiod. Essentially, when you look at the advice from Eurostat, etc., there's arguments which say, well, pros and cons for longer series versus shorter series, we just thought that we found that this sort of made sense. You'll note there's some overlap. Well, the overlap really is for the endpoint problem for seasonal adjustment. We'll come onto this later. Because it uses a centered moving average, for the last observations, it needs to forecast future outcomes. And for the initial observations, it needs some startup protocol. So by having overlapping periods, you can use the actual data, as it were, for the endpoints, and then throw it away and join up the series for the common chaining years. So that, for example, for 1997 to 2018, we throw away 2016, 17, and 18, and we throw away 1997 to 1999, and we just use 2000 to 2015. We then join that to the third series at 2015. Why did we choose 2015? Well, it's all a series of 100, so it's an obvious sort of point to do it at, and 2000. These things could all be adjusted, but that's the one that we chose. And so in this way, we're able to partially just avoid the endpoint problem that we'd be compounding by breaking up the series. And there's an additional bit we have for the all items and the 12-digit, two-digit COE-COP. We can use the historic CPI series to start from 1985. So we can go back to 1985 and use that as avoid the startup problem for all items and the 12 two-digit COE-COPs. But for 3 and 4-digit COE-COP series, we have to start from 1988. And so the only real endpoint issue that we have is from the endpoint that we have now in the last years of the series, because we don't know what's happening in the next in the coming years. So what were the results? Well, if we look at the levels and we compare the seasonally adjusted series to the original series, they're very close to each other. I won't show you a diagram because you'd just see two lines which are almost exactly the same. So, and they're within 0.8% over the 36 years. So there's very little. The seasonally adjusted series is close to the original series on average. There are some differences, but that's not so much. If we look at the annual headline, which is what's reported, it's always within 1 percentage point. There's one exception, which is January 1990, when the difference was minus 0.11 percentage point. But apart from that, the seasonal adjustment doesn't really influence headline inflation by much at all. Now, monthly is much more interesting. The mean is not affected. Seasonal adjustment doesn't affect, the means, but the standard deviation is almost halved. I'm exaggerating there; it's a bit less than a half, but clearly, this is what you generally find. Seasonality is a sort of systematic variability in monthly inflation. So when you remove seasonality, the seasonally adjusted series will be less variable. So here's a picture. Now, when you first look at this, you won't see much, so I'll just interpret it. So the original series, the OS, has a mean of 0.23%. That's quite a high monthly average, but of course we're including, for those of you, we had quite high inflation in the UK at the beginning of the series. In the late 80s and early 90s, there was quite high inflation. I think it peaked at 8%, the annual figure. And of course, you've also got the recent inflation peak, the cost of living crisis. So that's in there as well. Plus, inflation was quite high either side of the great financial crisis. So that's why the mean monthly inflation is 0.23. If we'd chosen different dates, it would be below 2%, 0.2%. The seasonally adjusted mean is exactly the same. But if you look, the standard deviation, now the brown figure here, that's the raw, the original the original series, and the blue, the dark one, is a seasonally adjusted series. Now, as you can see, the blue series tends to be more closer to the origin of 0% than the brown series, and there's lots of bits of brown bits sticking out. All the Januaries, for example. So there's a lot of seasonality in the brown bits, which is eliminated by the process of seasonal adjustment. And the standard deviation has gone down from 0.0043 to 0.028. So that's a significant reduction in month on month. So it's actually almost eliminated month on month seasonality. So here we have the brown bit is what I showed you before. Brown is the raw average of month on month seasonal monthly inflation across the 36 years. The blue one is a seasonally adjusted one. And as you can see, the blue lines are pretty much they're all lined up like ducks in a row, almost round about 2%, 0.2%. But as you'll see, April is still, it's not as cruel as it was before, but it's still pretty bad. And that's because, of course, it's got the outliers are still in there. And if you'll notice, October's there because, again, one of the outliers is the Ofgem October 2022, which was a very big increase, and it's that's still in the irregular bit, so that's why it's still there. But apart from that, we can understand that, and the seasonal the residual seasonality tests, it passes it despite this slight variation there. So that the differences are there, but they're not significant. So that's before and after seasonal adjustment. So seasonal adjustment is successful at the all items level. What happens lower down? Well, there are 140 series, so we do actually have a spreadsheet which has everything in it and lots of pictures. But the one I really like, though, is a classic seasonality. You can put this in your lectures if you want to. Clothing and footwear. Well, clothing and footwear, it's one of the most seasonal elements of COE-COP. And there's the level. So this picture here gives you the level of CPI. So you can see clothing has become much cheaper due to globalization. We used to make clothing in the UK, but now we don't. So it's the pre-mark effect or whatever. So clothing's become much cheaper in the 90s, and it's stabilized since the great financial crisis and gone up a bit in recent years. But the blue line is a seasonally adjusted line, and the brown is the original. So you can see these nice brown seasonal cycles that sales in January and July and so on and so forth going along. And what I also like, you can obviously look at the difference between the two. You can look at the seasonal elements, and you get this nice little diagram, which I really like. So that's a seasonal element, and I've expressed the seasonal element as a proportion of the original data. So you can see the clear seasonal patterns there, and you can see that seasonality has evolved over time. It's been bigger at certain times and smaller at certain times. The amplitude has altered, but the signal has remained fairly constant in terms of its pattern. So that's the most seasonal one. And you can do this, of course, for all of the series. For some of the series, of course, you can see here seasonalities are very important because some of these variations, it's going up to 3% or minus 4%. If you look at the left-hand axis, the y-axis, but for other things which are less seasonal, it would be much smaller proportions, less than 1% or 0.1%. So seasonality is more or less important for different series, but you'll see this sort of seasonal pattern. So that's seasonality then. So we've seasonally adjusted the data. So that's roughly what we've got. The second question, which is of great interest to the ONS, and it's something which is important, is that do we use direct estimation or indirect estimation? So let me just explain this. The COE-COP, the way we classify our expenditures and the different price indices that make up CPI and CPIH is a hierarchical system. You start from 4-digit COE-COP, and then you move up to 3 digits, and then to 2 digits, and then from 2 digits to all items. And the actual CPI, the original CPI data, it sort of adds up that at each stage, the expenditure weights used sum up to the total. So if you like, the total is the sum of its components. It adds up. And each individual series is chained each year as the expenditure weights change. But so that's how COE-COP works. So the indirect method of estimation is to start from the 4-digit level, or whatever the lowest level is. So some things like education are just at the 2-digit level. Some things like food and non-alcoholic beverages are at the full 4-digit level in these tables. But we go from the lowest level available, let's say, call it 3 to 4 digits for most parts of the CPI world, and then we build up from those estimates. We build up to the top. So we build it from the top. So the indirect method guarantees, if you like, that the seasonally adjust. If we start from the individual levels and we seasonally adjust them, and then we build up, that guarantees the CPI all items index will add up, will be the sum of all its components. Okay, now that's the indirect method, if you like. So what we actually do is we start from the direct method. We just directly do everything, all 140 series, and then we compare that to what we would have gotten if we'd have used the indirect method. Now, the indirect method is a little bit more complicated. You've got to do quite a lot of stuff to do the indirect method because each year uses different weights, and you've got to change them and take them apart and put them back together again. So it's quite an involved procedure to do the indirect method. It's not clear, but it can be done. It can be done. It can be done. So what's the main pro of the indirect method? Well, obviously, by construction, everything adds up. The higher level seasonal adjusted series are the weighted sum of the lower seasonally adjusted series. And indeed, this is what happens with the original series. So that's a big pro. And the ONS in general, where it does seasonal adjustment in other things for GDP and etc., this is the preferred method. That they want things to add up. The main con is really quite simple. I mean, it's the all items CPI and CPIH, which are the official statistics. We really want to have the best seasonally adjusted series for these. So, I mean, if we get something which is different, then it might add up, but we're gonna have residual seasonality, if you like, in the main items that the official statistics, which obviously isn't a very good state of affairs. So the way Monica and I approached this was we used a direct method for everything, and then we compared that to what would happen if we did it with the indirect method. We just simply said, is the direct method a good approximation to the indirect method? Because if it is, then it means they will approximately add up. And the question is, how close is the direct to the indirect, put it simply. So we did this starting from 3 levels. We can do it starting from 2-digit level and build it from there. We can go from the 3-digit and the 4-digit level. And we can compare the indirect methods from these 3 different levels to the direct estimates for the original series. And we get something, this is the picture we get at the end of the story. So along the horizontal axis, we've got the time. The vertical axis gives you the deviations of the indirect from the direct as a percentage. This is for the all items CPI, and we did it for well, this is for the all items CPI, which is the main thing. Okay, so as you can see, the blue line, the one at the bottom, that's the 2-digit. The 2-digit basically gives us something which is less than 0.5%. So that's pretty accurate, much less than 0.5%, in fact. If we start from the 3-digit level, that gives us something which is less than 1%. And if we start from the 4-digit level, 3 and 4-digit level, we go down to the 4-digit level, that gives us something which is within 2%. Now, if we look at this, before 2005, they were all within 0.5%. The deviations have happened since then. So what's our tolerance to the adding up error? Well, if it's up to 0.5%, then the all items CPI works with 2-digit indirect estimation. What that would mean is we'd use the direct estimates for the 12 2-digit COE, the familiar food and non-alcoholic beverages, alcohol, tobacco, clothing and footwear, education, so on. We'd take those direct estimates, and then we'd indirectly estimate the all items CPI and CPIH from that. If we're up to a 1% error, then we can go as far as 3 digits. And if we're tolerated 2% error, then we can go to 3 digits. So this seems to me, the adding up error doesn't seem to me to be too big. Even 2% in this context doesn't really seem to me to be a massive error. Oh, I might just add that this is the index. This is the error of the index. These errors make almost no difference to month on month or the annual headline whatsoever. So they'd only make a difference if you're actually looking at the index levels in tables 56 and 57. So month on month and annual, the error is much smaller. And indeed, if we start the process from 2015 rather than 1988, then all 3 are within 0.5%. So That's it. So really what we think is that we think the adding up error is so small that there's no point performing the additional work required to do the indirect estimation. So I think it saves on time. And secondly, the error is so small that it doesn't really matter anyway. So it saves on time and the error is small, so there's no reason to do it. So direct and indirect are a little different. The direct is much easier to implement, and it gets the higher level, which include the two official statistics, and it gives them the best seasonal adjustment possible. Okay, so how much time have I got? Anyway, revisions. So revisions are an inevitable part of seasonal adjustment. Now, I just want to say, I mean, I use a lot of ONS statistics, and revisions are part of non-seasonally adjusted series for lots of things. GDP most notoriously, of course, and its various components, but also purchasing power, producer price index, the effective exchange rates. There's a lot of series which are revised for various reasons, often because data comes in late or something is going on. GDP because there's balancing and so on and so forth. But, revisions are part and parcel of a lot of statistics within that the ONS produces. So revisions, we shouldn't be afraid of revisions. But of course, CPI and CPIH are a little bit special, as RPI was, and as the old Baxter report said, they're all subject to a no revisions policy. So even if they're just not revised. And what is it about seasonal adjustment that leads to revisions? Well, the main reasons are, the process of seasonal adjustment involves a centered mean. So the figure at time t depends on what's happening on t plus 13 and t minus 13. So there's moving averages and Henderson averages and so on. But these moving averages move around. So this causes an endpoint problem. If the present is time t, we don't know what the future values will be, and the x13 bit involves forecasts for future values at the end. So as we move forward, actual values replace forecasts, and this can change the seasonal adjusted models. Secondly, the underlying ARIMA model might flip. The best ARIMA models chosen using criteria like BIC and AIC, and this is applied to the whole series. As we move forward, there may be a switch in the best model, which can affect the whole seasonally adjusted series, even values towards the beginning of the series. And even if the underlying ARIMA model remains the same, the estimated coefficients may vary as the new data is added. So there are three possible bits there. There's 2 and 3 can be switched off if we only allow the ARIMA model and possible coefficients to change at fixed intervals. This is called partial concurrence. However, in a sense, this simply saves up revisions all to be made at the same time. But most of the NSIs that do seasonal adjustment do some form of partial concurrence. So in our analysis, we used full concurrence, and we looked at the extent of revisions at the CPI level for level, monthly, and annual inflation. And we used the revision triangle methodology to track the seasonally adjusted statistics for a particular date as you add more periods. So essentially what we're doing is we have an initial estimate made for time t, made at time t. So for example, January 2022. And then you track the deviations or cumulative deviations as you move forward. So you look at the estimate, the seasonal adjusted estimate for January 2022 as you go forward through 2022 into 2023 and so on. And we actually look at 24-month periods. And at the end of that, you have a final estimate. Well, it's not final because but it's a final in our window, if you like, and we can look at the cumulative distribution over the 24 months. So for those of you who are unfamiliar with these things, this is what it is. So here we have we go along the axis here. We've got the different months in 2023 to 2024. Here's the initial estimate for January 2023. And as we go down, we go down from January 2023 to October 2024, and we see what's the change to the index. In this case, it's the index, the cumulative change, and at the end we end up with the latest estimate. So the October 2024 estimate was the latest estimate, and that was 127.2, which was. The initial estimate was 127.1, and so we can track. Then we can do this for all of them. So we actually looked at 2 subsamples We looked at one relatively normal times, which was January 2016 to December 2017. So this is based on data starting from 1997. So the revision triangles, we're simply looking at the end of a long series, if you like. We're just looking at the revisions over a 24-month period as we revise them over those 2 years. But the data is based on data starting from 1997. And we looked at the case of turbulent times, which is January 2023 to October 2024. Based on data starting from 2012. So we have these two samples, and in table 4.1, we've got revision triangles. So we can look at summarize this data. So in normal times, the first bit, we've got 24 months of revisions, and the median cumulative revision for the index, the CPI index level, it was 0.03. Which, in that time, because 2015 is 100, the index is round about 100, so 0.03 is round about 0.03%, which is not very much at all. It's very small. And the largest absolute value was 0.82. So very small revisions at the index level. If we looked at the month-on-month value, the median cumulative revision was 0.02. Now, that's actually quite big. The average month-on-month inflation is round about, in that period, it was a little bit less than 0.2. Well, it's probably about 1.5 probably, but probably around about 0.2. So it's round about 10%. So the median revision for month-on-month inflation was quite significant, around about 10%. And the largest absolute value was 0.26 percentage points, which, if your average is around about 0.2, that's quite a big revision there. And if we look at the turbulent times, well, in absolute terms, it's almost exactly the same, except the signs have flipped. But the signs are the same. The percentage has gone down a little bit because in the intervening years, we've had a bit of inflation. So although the index, the median, is minus 0.03, whereas that was 0.03%, it's now 0.02%. Anyway, and we've added on also the annual figure, which we didn't put there, but the annual figure is very, very small, 0.06%, which is like 0.025 percentage points. So the revisions for the annual inflation rate are very, very small. And we could maybe reduce this if we had partial concurrence, but this seems pretty small to us. In the UK, there's limited reporting of monthly inflation, so this shouldn't really cause a big issue. And we discuss this in more detail in the report, how that could be dealt with, but it's not going to be a big issue. But for other NSIs, actually, I just noticed in its most recent reports, I don't know when it started doing this, the US Bureau of Labor Statistics uses the seasonally adjusted monthly inflation figure as a lead statistic in its monthly bulletins. So it says what the annual inflation rate is, and then bullet point 2 or 1 or 2, it's got the seasonally adjusted monthly inflation date. I don't know what most people, whether they understand what the seasonally adjusted monthly inflation rate is, but anyway, it's there. But this, I'm pretty sure the US data, that this will be adjusted as well. So it's possibly not a good idea. I wouldn't recommend the UK do that. So here's a diagram just to show you these things visually. I'd like to thank Paul Smith here. I did an earlier diagram on some earlier overheads, and the diagram was a little bit less clear, so now it's a bit clearer. So here I'm looking at month-on-month inflation. So I'm looking at the revision triangle. So basically, as we move along the bottom axis, we're moving through time, and each one of these lines represents the estimate for a particular month. And the particular month is the month where the line begins. So the blue line here, that's the January 2023, the estimate for the seasonally adjusted month-on-month inflation for January 2023. And here we see how it evolves over the 22 months here. The brown line is for February, and so on and so forth. So this is the month-on-month inflation. As you can see, yeah, these are quite big variations. If we look at this one, this is the blue line. I think the dark blue line is July. July starts off negative, but it even flips. So it starts off negative. The estimate for July, No, sorry, that's the August one. Sorry, I've got the right one here. I may have got the wrong one. But anyway, this one here, it seems to start on the August there. That's probably the estimate for July. Anyway, but this one, the blue line anyway, maybe August, it starts off negative and it even flips in 1 month before settling down, and it remains negative there. So here we can see there are some quite big changes there, and some of these are quite large proportionally. So this sort of just shows you how these different estimates evolve through the year. Now, we could do the same thing for the index revisions. So here I'm going back to 2016-17. So each one of these we start off again with an index. This is definitely July there, and that's definitely February. So this is a January estimate of the level for January 2016. So it varies a little bit, and they all vary, but they don't vary very much. And in fact, if you look at the left hand, the axis here, it starts at 99.6. So, there's a lot of, in order so that you can see the variation, I've zoomed in on it a lot. If I started it at 0, then you'd just see lots of you'd see lines which would be more or less straight and all collapsed on top of each other. So, there's a little variation there, but nothing very much. So that's the revision. So I think the issue of seasonal adjustment of revisions, I don't think it's a huge issue for the headline inflation figures. For month on month, it is, but for the index and the annual, the headline figure, I don't think it's anything that the ONS needs to worry about, and it just needs to be a bit cautious how it reports month on month inflation. As I say, it doesn't do it much nowadays, but if it did, it would need to do that. Be a bit more cautious. So, what are the conclusions then? Well, firstly, UK CPI and CPIH are seasonal, both in the sense of having within-year seasonality and autocorrelation at 12 months. But there's great heterogeneity. Some are very seasonal, like clothing and footwear. Some are not very seasonal. The policy effects are important. Indirect taxes, VAT in particular, and they often cause outliers, like the Ofgem rises in April and October 2022. And in the past, this was seen as a reason not to seasonally adjust CPI. So the ONS might take that decision, that they might think that they made the right decision 25 years ago, or not. But certainly the policy effects are key really here. However, as I say, other NSIs are starting to produce the season adjusted CPI and report it in their news bulletins. So it's maybe a useful statistic, and that there may be a call for it from users. So and the reason being, I guess, that if you take out the seasonal effect, it gives you a bit more of an insight into what the trend is in inflation. Where if prices fall in January, well, that just tells you that prices fall in January and you had January sales. But the question is, if you strip out the January effect, was inflation in January high or low relative to a normal month throughout the year? And so it gives you maybe a bit more insight into that. Okay, so we produce season adjusted series for CPI and CPIH, and 140 related series published by the ONS. So it can be done. And we compared the direct and indirect methods of seasonal adjustment and found there's no significant difference between them, in our opinion anyway. And we think that the direct method is the most appropriate because it gets the most important statistics correct, although it goes against the ONS norms. Lastly, we looked at revisions, and we really found that for the CPI index and the annual inflation, revisions are tiny, really. But for monthly inflation, they can be quite large. And that's it. So I'll stop there.
Thank you very much, Hugh. It's quite reassuring, some of that information, for sure. I mean, I've got some questions, but in the spirit of time, just want to encourage people. I know Josh Martin and Andrew Gurney have done so, but if you have any questions, please use the Q&A. I'm going to move on to Paul Smith very briefly. Paul is Professor of Official Statistics at the University of Southampton and currently head of Department of Social Statistics and Demography. Paul has worked with many aspects of the methodology of official statistics. He also worked many years, if I can remember. I remember him a long time ago in ONS methodology. Paul's recent research includes quality measurement for price indices, capture, recapture estimation with covariates, and small area estimation for business surveys. So there's going to be a bit of a assessment from Paul as a discussant of Hugh and his colleagues' work. So over to you, Paul.
Thanks very much. I hope we're okay to carry on a little bit past 1 o'clock, because I guess from here we will.
Definitely.
Yeah. So thanks very much to Hugh and Monica for that presentation of the work that's done there. It's all very interesting stuff, and this is based partly on the presentation and partly on the report which APCP saw. So I may say a couple of things in here that are not otherwise in the slides. I liked the little view back of history. I have some memories about RPI and how it was said not to be very seasonal, and therefore not seasonally adjusted, apart from this one particular series that took out the tax effects. I do remember some thoughts about Easter effects, and I remember that the only thing that really showed an Easter effect was flight prices, because the school holidays had an impact. And we didn't really talk anywhere in all of this about whether there are Easter or moving holiday effects in the CPI, because most of the time they don't matter, but Easter effects maybe do. So that's just a little bit of history in what I remember. Let me deal then with what Hugh has been talking about. So there's some really interesting stuff here, and I was fascinated by these other countries producing a seasonally adjusted consumer price index. You kind of said that they did it, and you talked about the Americans using it as a leading indicator. But why are they producing one in general? Are they all having this same idea that the 1 month change is a leading indicator and you have to seasonally adjust in order to get that? Or is there some other reason that other countries are producing a seasonally adjusted version? And I'll come back to that when I get to the last slide. But I think it would be really interesting to ask, why are we doing this? Is there a need which has been identified in other places which we're not meeting in the UK? I noted that we're using X13 ARIMA seats, or some version of that, inside the JDaMetra Plus software to do the seasonal adjustment. I wanted to ask whether this was really moving average based version, so the one that uses the X algorithms, the X13 algorithm inside, with just ARIMA for forecast extensions and not actually using ARIMA to do the seasonal adjustment. And the reason I think that's interesting and important is that the moving averages kind of account for what we can call moving seasonality, that the seasonality is not fixed over the whole length of the series, but it's allowed to evolve slowly as the series itself evolves. If we have that moving seasonality and we're allowed to use that inside the algorithm itself, then I don't see such a clear need to break up the series into 3 pieces. I'd be interested in a little bit more information about whether breaking up into 3 pieces has better effects on, for example, the revisions, whether we get a better quality seasonal adjustment in terms of the revisions triangles by doing the 3-piece breakup, or whether we can do all of that just inside a single pass of the algorithm by allowing the seasonality to evolve. Then I wanted to raise just a few issues off the slides. So the first one, and this one's a little bit more out of the paper than the slides, is about whether policy effects are allowed to be the cause of seasonality. So clearly there is quite a lot of seasonality in the series, and Hugh was showing the impact in April of changes in the tax regime, and those are coming through. There is a little bit of inconsistency in the approach, as I understand it, that's been used, in that in some series, like the ones that are affected by the Ofgem price cap, they've taken out the impact of the policy changes, the price cap changes, then done the seasonal adjustment and then pop them back. But at the top level series, when they seasonally adjust that one, they leave in the impact of the price cap. So it's not quite the same as adding up all the seasonal effects from underneath to get to the indirect adjustment at the top and comparing that with the direct adjustment. They're not quite doing the same thing, because there's this little inconsistency in how the impacts of tax changes are put through. But it seems to me logical enough that the tax changes, if they happen at the same time every year, are part of what we see. So those should be part of what we do deal with in the seasonal adjustment process. But we can maybe debate a little bit further how far we should go with those kinds of thoughts. The direct versus indirect seasonal adjustment I find really quite interesting. And as Hugh said, the default for ONS is generally to do indirect seasonal adjustment. But in my view of the world, that's a little bit more around getting the signal and noise, the trade-off between finding a signal and how much noise there is in getting that, more than it's about making sure that the series are completely coherent from adding up. The kind of argument here is that if there is a strongly seasonal 4-digit index, 4-digit COE-COP, then if you seasonally adjust that one first, then you identify its seasonality clearly because there's a strong signal and not much noise at that level. Whereas if you add that up to a high level, it might be having an impact at the top level, but that's a much smaller impact because you've weighted it up with lots of other series. And then the noise might be obscuring that effect. So the question here is whether you can do better with the seasonal adjustment at the low levels and then add them up. And it may be that, in fact, somewhere in the middle of those levels that Hugh was talking about is the right place, but that kind of needs investigation to see whether the signal versus noise bit is stronger at the 3-digit level, say, or the 4-digit or 2-digit or somewhere else. I was also interested in that diagram that Hugh showed, which shows the discrepancy between the direct and the indirect seasonally adjusted series. I was quite surprised that that discrepancy grows because really the mean, the trend of the time series, and Hugh did say this, it should be unaffected by seasonal adjustment. So that if the seasonal adjustment's doing what it ought to do, then there shouldn't be a change in the mean of the time series. In which case, if you add them all up, you must get back to where you started from. If you add up all the means and the means don't change, then the mean of the indirect seasonally adjusted series should be the same as the mean of the direct seasonally adjusted series. And the fact that that's not true and is consistently growing over a period of about 2003 to 2017 maybe just a little bit suspicious about what's going on in there. So I think that maybe needs explaining as to why that effect is in there. The revisions, I like the new plots here. They were very helpful. I take it that those are not unusually large overall. They do seem to be a bit larger in this month-on-month inflation, which is a little issue that I'm just coming to. And I like that we have the concurrent updating here so that we always have the latest information being used to feed into the seasonal adjustment. So just taking all of those pieces together and then thinking about how all that might be useful. So the annual inflation rate, as you said, removes the seasonal effects by construction effectively, or at least most of what's going on inside a series, because it's taking those 12-month lagged things, the 12-month changes, which means that there is no seasonal impact because you're comparing the two things a year apart. That gives us kind of a lagged view of what's happening with inflation because you have to wait 12 months before you can calculate the statistics so you see what happens. So in the kind of view that that's a kind of average, it's telling you something about inflation on average 6 months ago. So we would like to use monthly inflation just to give us, this is the kind of US argument, an indicator of the current trend in inflation, but that's much more noisy. And here it is affected by seasonality. So we'd like to compare what a seasonally adjusted version to remove those in-year effects, the ones that Hugh demonstrates that we can really see where January's was a lot lower and April's was a lot higher. But we can also see that that seasonally adjusted version is subject to big revisions, relatively big revisions anyway. So we kind of got a nice leading indicator that's telling us which direction inflation's going in, but it's noisy and it's subject to big revisions. So actually the amount of information it's giving you extra is not that great in my view of the world as to how this is here. Be interested to hear whether anyone thinks that's the wrong conclusion and there really is more information sat here than I'm seeing. So just to conclude, seasonal adjustments clearly a practical thing to do here. I was surprised by actually how many series really show some seasonality. What proportion of them? About 2/3. So it seems that there's something that can be done here, but I'm not completely convinced on the usefulness of it, at least at this stage. So that was me. Thank you.
Thanks for your insights there, Paul. There's some nuggets in there. In the spirit of time, there were a couple of questions in the chat, one from Josh Martin, but I think it was regarding levels of the seasonality, the seasonal adjustment and aggregating upwards, but you've implicitly covered that. And then there was Andrew Gurney, who's mentioned, isn't the 12-month autocorrelation a measure of inflation persistence rather than a measure of seasonality? And then I think if you take that plus Paul's response, you've got roughly 7 or 8 minutes, Hugh. But there's one more. There's a hand up from Martin Eaglesberger, and I apologise if I've got the pronunciation wrong. But Sarah, can you open the connection for Martin to come in? Martin, can you?
Martin, you should be able to just unmute now.
Hello, my name is Martin. Many thanks. My team and me, we are doing the season adjustment of the harmonized index of consumer prices here in the European Central Bank. And the reason why we do it in the European Central Bank is it's not provided by the statistical institutes. There's no tradition, according to our research, in Europe of doing season adjustment of price indices. It's mainly done of GDP, industrial production, retail sales. And for that reason, we do it internally. And I would first like to talk about the aggregation issue you identified. I have to apologize, I only joined lately, so I may have missed, but we are talking about the UK CPI, right? Which is the HICP, which is a chain-linked index. And this chain-linked index has the feature that it is not consistent in aggregation already before season adjustment. That's the first thing. And the second thing is that by doing the season adjustment, and let's imagine you talk about the December prices and the CPI is chain linked over December, and December prices are seasonal because of the package holiday effect over Christmas. And then you have, after season adjustment, you have a value for December that is smaller than the original value, and then you do the chain linking. So you have an impact on the trend because of the difference in the reference value for the chain linking. That's important to know. But you can't do anything about that. If you're interested, there's a paper by Jan Waldschotz at the Ottawa Group homepage you can look into. Jan was working for us as a consultant on exactly that topic, and he investigated it. So in case it's of interest of you, please have a look. I also wanted to explain that we do the season adjustment in the European Central Bank indirectly according to our user needs, to the needs of our economists. They are interested in the breakdown of the HICP into unprocessed food, processed food, services, non-energy industrial goods, and energy. Energy we leave out. We leave it not seasonally adjusted because we can't identify reliably a seasonality. The rest we do a season adjustment. For the services, we also do an ESCoE adjustment because according to the HICP rules, the services prices enter the index when the trip starts. Not when you do the booking, when the trip starts. For that reason, you have the seasonality in the index, and for that reason, we have an ESCoE effect. And we adjust for the ESCoE effect by just using the normal ESCoE dummies. We also use JDimeter Plus. We just play around with the interval, with the 1 to 8, just to get the best estimation for that. So we are doing that. And we also do in terms different to the Bureau of Labor Statistics. We look every month, and we have 2 releases every month, the flash estimate and the full estimate. 2 weeks later, we look into the factors and decide case by case whether or not we update the seasonal factors in order to minimize sort of revisions. So whenever we are not certain that the latest number indicates a change in the seasonality, we use forecast seasonal factors. Otherwise, we update seasonal factors. That's our main approach. There are some papers and boxes and communication. And in case you are interested, also I'm happy to contribute to the discussion bilaterally. I can send you my email address. Many thanks.
Yeah, thanks for that, Martin. Yeah, amount payable versus when it's consumed is always a big and tricky issue. So, amongst the other points you've raised. So, Hugh, there's a lot of issues raised, but you've got just under 5 minutes to do a summary of your thoughts of the bigger issues. I don't think you can cover them all. Over to you.
No, sure. But on the direct versus indirect, I didn't really have a chance, but to do the indirect, you've got all this dechaining. Basically, you have to dechain everything. It's quite an involved procedure, and we did suspect it was probably something to do with this that was leading to it. So I'd be very interested to read that research. It just simply, it's part of the project. We didn't really have time to go in to explore it. It's something that we would like to explore more ourselves, and maybe we can learn from the experience at the ECB and the. So that would be very, very useful. But yes, that no doubt has an effect. But we were just looking at the end result of it, if you like. What the end result was is it different or not, rather than explaining what the difference, the reason underlying the difference. That's unchaining. On the use of the statistics, I think this is quite interesting. I mean, you talked about Paul focused on this issue of giving an indication of the trend. I think I noticed with the US, looking at US economic commentators, what they often do is they look at a moving average of the last few months of monthly inflation, and they then annualize it, and then they give that's as if you like a measure they use as an indicator of what's going on. And if you're using a 3-month moving average, maybe it makes more sense to use a 3-month moving average of the seasonally adjusted inflation rather than the raw data. So I think that's maybe what's going on, why people are interested in this. I'm not quite sure. Colleagues at the Bank of England might be able to say something on that. But clearly, you want to, looking at the annual figure, it's summarizing a whole year. You might want to look at just last quarter's inflation, last 3 months or last 6 months as a guide. And if you're doing that using a partial within year, less than 12 months, then maybe it's best to use seasonal adjustment, though obviously the revisions will cause problems. So I think that's that. On the indirect revisions, the issues raised by Paul, I think, yes. Would you like to comment on breaking the time series up into 3? It's something we found when we first did the whole series. We found we still had some residual seasonality left in the series. We then broke it up into 3, and so it may be that we could do it as a whole series if we wanted to. But I know Monica's a fan of doing it, and I also thought it's a practical issue for the ONS. So they only have to look at the last 15 years, what's happened past 2015. They can put to bed everything before 2015 and just leave it where it is, rather than having to do the whole series each month. When because remember, for the ONS, they're producing the original series already, and then they also have to produce to a deadline this extra data. So it's something which is it's quite time sensitive. Do you want to say anything on that, Monica, or you don't have to, but.
I think in general, we found that when we broke the series, the quality measures produced by JD improved. So when we used the full series, there was large fluctuations in the seasonal component and significant moving seasonality. So this improved by breaking the series. Part of this could also be that some series start off as seasonal and then do not become seasonal in recent years, and vice versa. So it's quite a long series, like 40 years, and the dynamics change a lot. So breaking the series helped us look into this a bit more, but there could be other ways to deal with these issues as well. But also the practical part that you mentioned, that it doesn't make too much sense to review data back to the 80s or 90s every month.
Okay, thanks for that, Monica. Right, you got less than a minute, Hugh, but Martin's come in. So Martin, very quickly.
Yeah. Just very quickly on the decomposition approach. My impression is that it's coming really from the X11, X12, because it's a much older program. You may know Tramoseeds. That's the completely integrated ARIMA-based program. I have the impression the decomposition is more done on a technical level because users expect it, but it's not really required, as you explained, because it's fully integrated ARIMA model. And actually, in terms of history, if I saw it correctly, it was Peter Berman in the early 1980s from the Bank of England who came up with this idea. Really impressive. And then it was elaborated by Agustin Marabal, who worked many years for the Banco de España. So actually, from a statistical perspective, but you're much better statisticians than I am, I find it more attractive because it's an integrated approach. And indeed, I would agree there you wouldn't need so much the decomposition. And also when you compare the irregular component with the residuals and Charmosites, it's completely different. So and what you get in X11, X12 as an irregular component really doesn't look like it should be if you come from the time series analysis perspective. That's at least my observation.
Thanks for that, Martin. Hugh, 15 seconds to summarize.
Well, we didn't. I mean, there are many alternatives within the general X13 world, and we didn't explore all of them. We had a time limited project. We wanted to get something which is robust and practical. But there are lots of for seasonal adjustment specialists. There are a lot of issues which we just simply didn't have time to resolve, but which are very interesting, we might well look into some of these as well.
Yeah, seasonal adjustment will go on for a long time. So thank you very much for that. Thank you to Paul and Hugh for the session today, and thank you for you all joining. Just a reminder that the next ESCoE webinar is on the 2nd of April. Thank you, and good afternoon or good evening wherever you are. Okay, bye.
Bye.
Thank you. Bye.